Hello everyone. This video is an introduction to classes and objects in Python. We will explore the fundamental concepts of object-oriented programming in Python. Let's begin. Let's understand what classes and objects are. Classes are like blueprints or templates. They define attributes, which are data, methods, which are functions, and provide a way to create objects. Think of it as a cookie cutter that defines the shape of a cookie. On the other hand, objects are instances of classes. They contain real data, represent specific examples, and can perform actions via methods. Objects are actual cookies that are created using the cookie cutter. So, a class is a general template, and an object is a specific instance of that template. Now let's see how we can create a class in Python. To create a class, you use the class keyword, followed by the name of the class. Inside the class, you define attributes and methods. The __init___ method is a special method, also known as the constructor, which initializes objects when they are created. The self parameter refers to the instance being created. In the example, we define a class named person with a constructor __init__ that takes name and age as arguments and assigns them to the instance attributes self.name and self.age. We also define a method called greet that returns a greeting message using the person's name. Now that we have a class, let's create some objects from it. To create an object, you call the class name followed by parentheses, passing in the necessary arguments for the constructor. In the example, we create two person objects, Alice with age 25 and Bob with age 30. We can then access the attributes of these objects using the dot notation. For example, Alice.name will give us Alice, and Bob.age will give us 30. Here we see a class blueprint on the left and how it translates to Alice and Bob objects on the right. Each object is a separate instance of the person class with its own data for name and age. In Python classes, we have three types of methods: instance methods, class methods, and static methods. Instance methods operate on individual objects, and the first parameter is always self, which refers to the instance. Class methods operate on the class itself, are decorated with @class_method, and the first parameter is CLS, which refers to the class. Static methods don't operate on objects or the class, are decorated with @static_method, and have no special first parameter. In the example, we have a MathUtils class with an instance method, calculate_area, a class method, from_diameter, and a static method, is _positive. Each type of method serves a different purpose and is used in different scenarios. Inheritance is a powerful feature in object-oriented programming that allows a class to inherit attributes and methods from another class. The parent class, also known as the base class, provides common features, while the child class, also known as the derived class, adds or modifies functionality. We use the super function to call parent class methods from the child class. Inheritance promotes code reuse and logical organization. In the example, we have an animal class with a constructor and a speak method. The dog class inherits from animal and adds a breed attribute and overrides the speak method. This allows us to create specialized classes based on a common base class. Now, let's see how we can use inheritance in practice. We can create objects from the inherited classes and access their attributes and methods. In the example, we create a dog object named Rex and a cat object named Whiskers. We can then access their attributes such as name and breed, and call their methods such as speak. Inheritance allows us to create a hierarchy of classes, where child classes inherit and extend the functionality of their parent classes. This makes the code more modular, reusable, and easier to maintain. We see here the animal class at the top and dog and cat classes inheriting from it. Encapsulation is the bundling of data and methods that operate on that data within a single unit, which is a class. It helps in hiding the internal state of an object and protecting it from outside access. Python provides 3 levels of encapsulation: public attributes, which are directly accessible, protected attributes, which are indicated by a single underscore prefix, and private attributes, which are indicated by a double underscore prefix. Getters and setters are methods that control access to data and allow us to perform additional operations such as validation. Encapsulation helps prevent accidental modification of data and makes the code more robust. In the example, we have a bank account class with public, protected, and private attributes, along with getter and setter methods for the private attribute balance. Polymorphism allows objects of different classes to respond to the same method call in different ways. It provides flexibility in code design, creates more intuitive interfaces, and makes the code easier to extend. In the example, we have a dog class and a cat class, both with a speak method that returns a different sound. We then define a polymorphic function animal_sound that takes an animal object as an argument and calls its speak method. The same function works with different objects, producing different results based on the object's type. This is polymorphism in action. Let's summarize the best practices for object-oriented programming in Python. It is always advisable to follow PEP 8 naming conventions, keep classes focused on a single responsibility, use docstrings to document classes and methods, avoid deep inheritance hierarchies, and prefer composition over inheritance when possible. To summarize the key takeaways, classes provide structure and organization, objects bring data and behavior together, inheritance promotes code reuse, encapsulation protects data integrity, and polymorphism creates flexible interfaces. Thank you. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.